it's on. Now, if you look at this whole chapter, it's first about energy, and that is always conserved. And then we talked about 3 different types in which heat can be transferred, which is conduction, convection, and radiation. And now we're actually looking at one particular form of energy, usually electrical energy. And we're going to do some calculations with it. Jinx, yes, most definitely. Probably in the way of me sending the answers to you, but also in such a way that you can ask some questions about that. Jinx, yes, we will. Okay, go, then caboodle. Alright, so we're going to focus on electrical energy, which means that we're going to have a look at power too. And like it says on the screen, the power of an appliance is the amount of energy it uses if it's on. And there's also a way, if you know the power and you know the time it's been on, you can calculate the energy. Like this, energy is calculated with multiplying power times time. So in formula form, that is energy equals powers times time, or E equals P times T. And pay note that's capital E, capital P, and a small t. If you would put in a capital T there, that would be temperature, and that would make no sense. Energy can be calculated in 2 units. Now, usually energy is calculated, things are calculated in 1 official unit in science. Energy is different because you have like the scientific unit, you have the units energy companies use, so you actually have to learn both. So, there we go, this is the formula again. You can take the power in watts and the time in seconds, you get the energy in joules. Take the power in kilowatts, the time in hours, and you get the energy in kilowatt hours. And pay note, this is not kilowatt per hour, this is kilowatt hours. So, let's have a look at an example. Now, what I just told you is revision, so you should have said a million. This example here. So let's say heater as an oven, its power rating is 2,400 watts. So that's the power of the oven. That says something about the energy it uses if it is on. If it is not on, it doesn't use any energy, obviously. So baking a loaf of bread takes 30 minutes at full power. How much energy did he spend? Now you can actually calculate this energy in 2 ways. Of course, the energy amount is the same amount for the loaf of bread. But you can express this into units, like I'm going to show you. So baking a loaf of bread takes 30 minutes full power. How much energy did he spend? And we're going to have a look at the energy in joules first. And that means we take the power in watts and the time in seconds, which is easy enough because the power is already in watts, so you don't have to do any conversions there. The time is in minutes, so you have to convert 30 minutes to seconds. Now, I hope you guys know that every minute has 60 seconds, so 30 minutes, 30 times 60 seconds is 1800. So we have the power, P is 2400 watts, T is 30 times 60 is 1800 seconds, and you put that in the formula, so you multiply power by time and you get the energy, which is 4,320,000 joules, which seems like a lot, but a joule is actually not that much energy. So this is correct. So I also converted it to kilojoules to make the number a bit smaller. I could have converted it to megajoules, and it would have been 4.32 megajoules. But you don't have to, obviously. So this is how you do it if you have to calculate it in joules, which is the official science energy unit. Any questions about this? Yeah, all right. down to the same calculation, but now in kilowatt hour. The formula is the same, but the units are different. So we still take the power and the time, we multiply them to get the energy. But now we take the power in kilowatts and the time in hours. So here we go. What I do is I take power in kilowatts this time. So that's 2.4 kilowatts. I take the time in hours. Now 30 minutes is half an hour. The formula for the conversion is to divide the amount of minutes by the amount of minutes per hour. So that's 60. So you divide 30 by 60, then you get 0.5 hours. On the other hand, it also makes sense. 30 minutes is half an hour. We know this, so you can just put it like that. Then you put it in the formula. Energy equals powers times time. It's 2.4 times 0.5 is 1.2 kilowatt hour. So this number is way smaller. If we go back to the other one, you could tell it was 4,320 kilojoules. And as you can see here, the same energy can also be expressed as 1.2 kilowatt hours. So that means that 1.2 kilowatt hour is equal to the 4,320 kilojoules, which is true. So we got one amount of energy, but expressed in two different units, in kilowatt hours and in joules. Any questions about this? Do you need more time to copy it? No? All right.
I do.
Sorry?
I do need more time.
Okay. We'll stick to this then. What I was going to say was, in science, there is usually an official unit, which is also true here. The official unit for energy is the joule, as the official unit for time is seconds. These are official in the sense that there's actually an organization that deals with these units and sets them, defines them, because you can say, okay, how long is 1 second? We can say, well, it's 1/3,600th of an hour, but then how long is an hour? Well, it's 1/24th of a day, so there's always a problem of definition, but this organization also defines them, sometimes in surprising ways. All right, do you need to do, Jinx, you need to be able to do them? Yes. Energy and power. So science unit is joule. The reason we use kilowatt hours is because energy companies for consumers use the units kilowatt hour. And other units exist, like phone batteries. They use milliampere hour, which is yet another type of energy unit. Another energy unit would be the calorie. The calorie is defined as the energy needed to raise 1 milliliter of water 1 degree in temperature. So, and that's usually used for food. Also, straight away convertible to other units of energy, but not one we often use in science. It has the convenience that it's very easy to use if you're calculating temperature differences in water. All right. Now I have a small assignment which we'll do in the lesson, don't worry. So what I want you to do is you are at your home, and what I want you to do is go have a look at your electricity meter. Where you can find it depends on your home, because I don't know how it is, but usually you have what we call a fuse box in English, meterkast, which is probably located near the front door. And what I want you to do is go have a look at your own fuse box, try to find energy. There's actually two. There's one that counts the gas coming in and out of your house, and there's another one that measures the electricity, and you need the second one. So go have a look. So get out from behind your computer, with you so you can take a picture and try and find the energy meter. If you don't know, you can ask your parents. So go now. We'll talk about it in maybe 5 minutes.